Let's talk about a couple of the main ideas for what is going to be probably the biggest theorem that we'll talk about all semester. It's called the central limit theorem, and it deals with sampling distributions and estimators. So let's say that we roll a dice 5 times and we find the mean. Let's say the first time that we get a mean of 3.4, and the second time we get a mean of 4.1, and then a mean of 2.7 and 4.0 and 1.9 and 2.5 and 3.8 and so on. If we were to take the mean of all of these means, we would get a population mean of 3.5. So the mean of these means tends toward 3.5. Here's what we're talking about. This is a sampling distribution. The sampling distribution of any statistic is the distribution of all the values of the statistic when all the possible samples of the same size n, so rolling a dice 5 times, are taken from the same population. Specifically for the mean, the sampling distribution of the mean is the distribution of the sample means, with all the samples having the same size n taken from the same population. Let me show you a picture of what I'm talking about. If we went to our example and we drew a picture of all of those means, we'd have our first mean of 3.4 and the second mean of 4.1, and then 2.7 and 1.9 and 4.0 and 2.5 and 3.4 and 3.8. And our mean of our means in the middle would be 3.5. And all of these sample means, so means of smaller samples, only 5 rolls of the dice, all of these sample means would form a normal distribution. The sample means close to 3.5 would be in the middle. There would be the most of them there. And the sample means that are higher or lower in the extreme, 1.9, 1.2, or 5.0, or 4.9, those would be at the extremes. So all of the means tend toward a normal distribution. These sample means, we say, target the value of the population mean. So if we could roll a dice 5 times over and over and over again for an infinite number of times and find the mean of those means, we would get a population mean of 3.5. Finding the correlation between the mean of the sample and the mean of the population as a whole is really crucial, because usually we can't sit around for eternity rolling dice and finding the mean. So finding the mean of a small sample is what we're going to be concerned with in most of the rest of the semester. Now, mean isn't the only statistic that we can do this with. So going on to the next idea. Oh, I'm sorry, I forgot. The distribution of the sample means tends to be a normal distribution. So when I plotted all of those sample means on the last slide, they made a normal bell-shaped curve. Okay, other statistics for sampling distributions. The sampling distribution of the variance is the distribution of the sample variances, with all the samples having the same sample size n, taken from the same population. So let's say you roll a dice 5 times and you find the variance. Remember, the variance is the square of the standard deviation. So let's say we get a sample variance of 2.7 and then 1.9 and then so on. And we find the variance of all of those sample variances. The population variance would be 2.9. And we would say that these sample variances target the value of the population variance. And the distribution of these sample variances tends to be a normal distribution, or a bell-shaped curve. And then the third sampling statistic we're going to look at is the sampling distribution of a proportion. That is the distribution of the sample proportions with all the sample having the same size n. So if you roll the dice 5 times, and let's say you find the proportion of odd numbers that show up. So the first one of your 5 rolls turns out to be odd. So you have a proportion of sample proportion of 0.2, and we use p hat for that. And then you do it again, and you get 3 out of your 5 rolls shows an odd number, so 0.6, and then so on and so on. The proportion of odds over all of your proportions would be the population proportion of 0.5, which makes sense. If you rolled a dice forever, you would expect about half the time you would have an odd number showing and half the time you'd have an even number showing. And these sample proportions target the value of the population proportion, 0.5, and their distribution tends to be a normal distribution. Because of this, we call the sample mean, the variance, and the proportion unbiased estimators of the population mean, the population variance, and the population proportion, because they target the population parameter. The sample median, the range, and the standard deviation are called biased estimators of the population mean, the population range, and the population standard deviation.